Let's start with a simple question. 5 letters are selected at random from the 9 letters in the word celestial. Find the number of different selections if the 5 letters include at least one E and at most one L. So the way I like to approach this question is to first note down how many E's there are and how many L's there are. So in this question we have 2 E's and we have 2 L's. So 2E, 2L. And I like to just cross them out from the word to make it simpler. And now we list down all the scenarios of 5 letters including at least one E and at most one L. So we start with one E and at most one L. So one E, one L. That leaves us with 3 empty slots. Then we have one E, no L's, so 4 empty slots. Now we move on to 2 E's. So we have 2 E's, at most one L. So leaving us with 2 empty slots. And then 2 E's with no L's. So 3 empty slots. So now we look at this with one E and one L. The first 2 options of the letters are included already, which is leaving us with 3 empty slots. So now we have the letters C, S, T, I, A, which is 5 letters. So that means from the 5 letters, we are going to choose 3 different letters, meaning 5, C, 3. And then for 1E, we have 4 empty slots. So that means we're going to choose 4 letters from 5 different letters. So 5, C, 4. And then so on. 2 empty slots is 5, C, 2. And with 3 slots is 5, C, 3. And to calculate, 5, C, 3 would be 10. 5, C, 4 would be 5. 5, C, 2 would be 10. And 5, C, 3 would be 10. We add all those up, that would equate to 35. So the answer to the amount of different selections would be 35. But now let's look at this question. 4 letters are selected at random from the 8 letters of the word tomorrow. Find the probability that the selection contains at least one O and at least one R. So now this question is asking us for the probability. So let's define what probability is. It is the favorable outcomes over all outcomes. So we'll begin, let us find all the favorable outcomes, which is basically the same way we did with the last questions, all the selections. So let's look at the word tomorrow. We count how many O's there are. There are 3 O's and there are 2 R's. So 3O, 2R. We cross them out. O, O, R, R, O. Okay. Now we look at all the different scenarios. So at least one O and at least one R. So let's start with one O. So one O, one R. 2 empty slots. And then we go to one O, 2 R's, 1 empty slot. And then we go to 2 O's now. 2 O's, 1 R, 1 empty slot. 2 O's and 2 R's. And lastly, let's go to 3 O's. So 3 O's, at least 1 R, so 1 R. That should be all the possibilities. But now, be careful. This is where a lot of people will fall into this trap. Looking back at the word tomorrow, we have T, M, and W left. So 3 letters. And for OR and 2 empty slots, a lot of people would answer 3C2. Which honestly makes sense because we have 3 different letters left and we have 2 empty slots. So 3C2. However, let's look back at the question. The question is asking us for the probability, which means we are referring to the chance. And hence, although we are already fixed with having one O and one R, we have to consider that there are 3 possible O's and 2 possible R's. This means that we are randomly choosing one O from 3 O's, and there are 3 different ways to choose one O. And what does that equate to? Well, that's simply 3C1 for the O's. And for the R's, the same thing. We are randomly choosing one R from 2 different R's. So there will be 2 different ways to choose one R, right? And what does that equate to? Well, That's just 2C1. And now with the 2 empty slots, we do it as we do usually, which would be 3C2. And that's it. Let's look at the other ones. So now we are choosing one O from 3 different O's. So of course 3C1. But now we're choosing 2 R's from 2 R's. How many ways would that be? Just one. And that would just be 2C2. One empty slot, so 3C1. Now we have 2 O's. So we're going to choose 2 O's from 3 different O's. That would just be 3 options, would be 3C2. And then 1 R again is 2C1. One empty slot, 3 different letters, T, M, and W. So 3, choose 1. Now with 2 O's again, so 3C2. 2 R's would be 2C2. And no empty slots. Sure, we can just write down 3C0. Which is just 1, but you know. And now we have 3 O's. So 3 O's, choosing 3 O's from that, just be 1. So we write 3C3. And then 1 R, 2C1, no empty slots, 3C0. So now the first one would be 3 times 2 times 3. Then we have 3 times 1 times 3. Then we have 3 times 2 times 3. And then we have 3 times 1 times 1. We have 1 times 2 times 1. So 3 times 2 times 3 would be 18. 3 times 1 times 3 is 9. 3 times 2 times 3, 18. 3 times 1 times 1, 3. 2 times 1 times 1 is 2. You add all that up, you would get 50. So that's all the favorable outcomes. But wait, hold on. That's not the end of the question. Remember, we're asking for the probability, which means we still have to find all outcomes. So now, the same thing applies for the total possible outcomes. However, with the word tomorrow, TOMORROW, a lot of people, usually in this case, because there are only 5 different letters, TOMRW, and we're trying to find 4 different letters in the selection, a lot of people would usually just do 5C4, which is correct in finding all different selections usually. But remember again, the question is asking us for the probability. So, and because of that, we are trying to count all the different letters in the word tomorrow individually to find the chance. So all the O's, all the M's, all the R's, all the W's, all the T's are all considered different letters in this case because we're trying to find the chance of choosing one of them. So all O's, let's assume all the different O's are different letters, although they are still O's. So in this case, we have 8 because there are 8 letters in the word tomorrow, and we choose 4, which would equate to, let me just calculate that. That would equate to 70. And so now we have all the favorable outcomes and all possible outcomes. So that would be 50 over 70. And to simplify, that would just be 5 over 7. And that's our final answer. Well, anyways, here's another question you guys can try at home with the same application as the tomorrow question. Why? Well, simply because of the word probability. Well, honestly, to summarize everything I've said before, these type of questions don't appear that much in Cambridge, the combination plus probability questions. However, reading the examiner reports, reading everything I've heard, a lot of people don't really understand this concept. And although it's rare, if you do understand it and maybe in the future it does come out, this can be a big boost to your grades. So I believe it is very important for you to understand this as well. And remember, this concept of counting all these repetition letters individually, counting all the probability, all the possible outcomes, even though it's repetition, is only applicable with the word probability when we're trying to find probability with selections or combinations. So be careful. Don't stress yourself too much on this topic, but please keep in the back of your head that if it's probability and combination, do it this way. Well, that's it. Thank you guys for watching.